focus on one of his networks, the DSN. I'm the Deputy Project Manager. My boss, Al Bonji, is here. Raise your hand, Al. Let people see you. He's the project manager. And Jeff Osmond's here somewhere, too. He's floating around. Jeff, a longtime DSN person, he's responsible for the management of the contract that operates this facility, working very closely with ITT Excelis. He's very knowledgeable. He prepared these charts. He's standing close by in case you guys have some questions that I can't answer. Go to the next chart. DSN. We operate out of HEOMD, the Human Exploration Office and Operations. JPL has been given the responsibility by NASA to operate the DSN. That's both operate, maintain, infuse new technologies, and we take that charge very seriously. What you'll see is that when missions launch, regardless of whether it's a NASA mission, one from Japan, European, even the Indian Space Agency, when it launches, its only communication ability is through the DSN once it gets out past the moon and beyond. The way it gets commands to it, the way it responds to anomalies, we have to have a network that's very reliable, very responsive, and pretty much fault tolerant. When MSL did its landing, we had both this complex and the Australian complex overlapping, tracking the spacecraft as it went into the atmosphere. We had alternate assets from the European Space Agency also looking at it. And during that process, we were also looking at the orbiters, Mars Odyssey and Mars Reconnaissance Orbiter, to be able to relay data once the lander started to relay data through those orbiters. So it's a very complex system. It's a responsibility that we take very seriously. And in addition to having a responsibility to I think last time we checked, there was almost $23 billion worth of assets that we track on a regular basis that rely on us for its health and safety. We also have a responsibility to the environment, so we take that very, very seriously. We have an environmental program that we have to employ both here, meeting Australian and Spain requirements as well, so that when we develop something new that's going to be deployed throughout the network to 3 countries basically, it has to meet all the requirements. So we take that all very, very seriously, and we have a very, very, very limited budget that we get from Badri. Very limited budget that we get from Badri. And amplify that a little bit. We're actually...
Keep it up and you get this.
We actually carved out some money to build some new antennas. We have one under construction in Australia as we speak. You actually will see, I believe you're going to see a little bit later, the 70 meter, our prize antenna. We have one of those at each of our complexes around the world. But I believe when you get near, if you look off to your left, you'll see a high efficiency antenna. It's not the beam waveguides that we're building now. It was a predecessor to that, where the electronics are actually up in the cone, up in the dish, and it moves when the antenna moves. The design we have now that we're building now are beam waveguides. I don't know if the tour is going to show them a beam waveguide. It is? Okay, good. That's what we're building down in Australia right now. Eventually we'll add 3 to Australia, 2 to Spain, and 1 here, so that we get 4 beam waveguide antennas available to back up the 70 meter should we have problems with the 70 or we have to take it down for long time maintenance. Badri alluded to World's Toughest Fixes, a Nat Geo program. It did a very large segment on the 70 meter here where we actually lifted the antenna, replaced the runner, replaced the grout. It's a huge undertaking, a huge feat. So we're about to undertake replacing the grout at the 70 meter in Australia, to be followed by the 70 meter in Spain, which will help in our maintenance, long-term maintenance. Marie, can you go to the next slide?
And just to show you how tough it was, his back is still hurting from lifting it.
Yeah. You will see, if the shot's available, there is a picture of myself and William Rafferty, one of our bosses, standing next to the antenna as it's being worked on. And it kind of appears that he's holding the antenna up, and I'm standing right next to him. Explorer 1 back in 1958, that's where the DSN's history started. I think we've already mentioned all the different missions we support right now. We supported missions that are currently gone. One of the unique things about the DSN is Missions stay around, so we have to keep those capabilities to support those missions, in addition to new missions that bring in new capabilities that we have to support. Missions that have a data rate of 10 bits per second, missions that have megabits per second, we have to be able to support both areas of it. Next. Tracking, telemetry, command, radiometric, DSN science. One thing we do in that environment, you'll hear a little bit about the 70 meters used to support DSN science. I think when you get out there, I don't know if it's Bob or Gary or someone's going to talk about how we do science with these big 70-meter antennas. They're precise instruments to be used in science. Our bread and butter is really tracking, telemetry, and command. That's the way we get commands to the missions and get the data back. So when you see data in textbooks that have come from a Cassini or a Galileo or a Mars orbiter, that came through the DSN. We help make that possible. Unfortunately, we don't charge them for that. Or we might be able to build some new antennas faster, but our service is provided to the missions basically free. It's part of the infrastructure that NASA uses to keep the missions running, keep the missions alive. I don't think I want to spend too much time on this chart. Is there a point where we have questions and answers?
Yes.
So am I supposed to get through this and then questions and
And
answers?
they can, yes.
Okay. All right, so let me try to get through these as best I can, and then we'll answer some questions. Next slide, Marie. We have, as Badri said, we have Australia, Spain, and Goldstone. That's our three major sites. There's a 70 at each site. There's a 34-meter high-efficiency antenna at each site, and then there's, depending on which location you're at, the most 34-meter beam waveguides are here. We have 5 here, 2 in Spain, and one in Australia. That's why we're building in Australia first. It's got the fewest assets, provide the fewest links, and come 2015, we have celestial dynamics is coming into play, and a lot of our missions will be over the southern hemisphere, thus the need to add a new antenna. So that's what we're working to. JPL is where the Deep Space Operations Control Center is. Most all the data comes there. That's the way it gets distributed to the mission operations center, all the project locations around the world. We have the circuits to the DSN sites. We have an alternate location here. Actually, this building houses an emergency control center. Should we lose building 230 at JPL, the central processing area, we would then operate from here and from the emergency control center. It provides a very limited backup capability, which we're working on. For those of you who are familiar with Southern California, there was a stations fire several years ago where JPL had to be evacuated. We operated remotely to support the missions at that time. One of the few times we've actually exercised a backup facility in actual heat of battle. So that was quite interesting. It was something we were really proud that we accomplished. Marie, next slide. This is kind of a description of what each of the complexes has. As I mentioned, the 70, the 34 meters. They have a central signal processing facility. You're going to visit that when you're out at the 70 meter. Each one has a central signal processing facility at each of the locations. That's where all the data is remoted back to there and then sent from there back to JPL and then on to the missions. We have a wide variety of things we have to deal with. Roads, utilities, bathroom, sewage, plus the antennas. We have just a myriad. We have 3 cities operating around the world. Each has its own power source if need be. We have commercial power to all 3 sites, but we also have generator power that will power the entire facility. This facility actually has an UPS, so the entire complex, should the power fail, gets picked up by backup power supply, and then the generators come on and will drive power to all the complex. So this is something we're doing. We have that same capability in Madrid, and in a couple more years we'll have that capability in Australia. So it's an expensive undertaking. For example, when we go on generators in Australia, as we did for the MSL landing, we spend about $10,000 a day on fuel. This has to be planned for. It's something we use our money very wisely. We take spending taxpayer dollars very seriously. And we really enjoy when people come out, like you, to see it. We're very proud of what we've done and what we're going to do in the future. Next slide. International. Primarily we support NASA missions, but we also support the Japanese Space Agency, the European Space Agency, the Indian Space Agency. We supported the Chandrayaan mission that went to the moon. They are planning to launch a mission to Mars next year, next November. We've been asked to support them. So anytime we're needed, we try to support as many missions as we can. We have about 36 we support on a normal basis. Another 12 we support on an emergency basis, where we had supported them at launch. They get handed off to either the European network or the Indian network. That's their primary network. And then if they have problems, they would then use us. As Bobby mentioned, our large antennas can really get a signal into a spacecraft when they're having problems with their telecom system. Next slide kind of tells us what we're unique. As I mentioned before, we have missions that are at 10 bits per second, and they go up to 6.6 megabits. We have some missions that are currently scheduled to launch later, in about 3 or 4 years, that will exceed the 6.6 megabits, so we're upgrading our systems to be able to accommodate that. We use a 20 kilowatt transmitters. The large aperture gives us a high performance so that we can get the power to, like Voyager. Voyager mission can only we can only transmit to Voyager, correct me, 1 or 2, Voyager 1 from Australia. Voyager 1. Voyager 2 can be tracked by the other locations that we have. The Voyager 1 only we can only transmit to it from the southern hemisphere. So they rely very heavily on our abilities to be there when they need us. So let me wrap that up and then spend some time answering some questions for you guys. And I'm going to ask Jeff to help answer any questions you may have, and Al.
Questions? Don't be shy, guys. I know you got them.
I have a question. Which mission has a 10-bit per second data rate?
Voyager transmits 10 bits per second. A lot of this, believe it or not, when a mission goes into a safe mode, or emergency mode, several of the missions use 10 bits per second as their emergency mode. Having been on a mission, it was something that was built in early in the design phase, but what they find out is they don't want to be at that rate very long when they're in an emergency. They want to be able to bump that rate up, but it gives them at least some housekeeping information that we can lock on and give to them that tells them what's going on in the spacecraft. But Voyager primarily.
So your notional network of 2015 and the optical communications and live streaming video from Mars, everything looks really exciting. Is the budget in place to make that happen? Is that coming?
Well, I'm going to defer to Baudry on that one. He has the money.
There is a strong commitment. Nobody can talk about the budget so many years down the road. We don't know how it's going to be. We fight for our budget. We work our budget with OMB, and we work it later on. Congress give us the money. So we cannot predict whether they will give us more or less. But we look at the trend. You know, even if we continue the way we are going now, they keep us flat, probably adjusting for inflation, we'll find the money within the program. It's a priority for us, and we are investing a lot of money on optical communication. The demo to the moon, it's not coming cheap, you know, because we are evolving new technology suitable for a near-Earth environment as well as from deep space. You know, when we go to operate and maintain these capabilities, our plan is not to have different infrastructure for near Earth and another infrastructure for deep space. To use the same infrastructure, because O&M and ground infrastructure can result in so much cost, you know. So we are approaching it by harmonizing the technology that can be used in both places. So we are spending a lot of money. I have other priorities for now. Otherwise, I would have put a lot of money on optical communication for the immediate future. like building the 34-meter antennas that comes, we didn't get any new money. We had to take the money from within and reprogram it. So that's what, when I talked about efficiency. The sustainment of the ground infrastructure is hundreds of millions of dollars that we needed to rejuvenate the ground infrastructure over there, to prevent catastrophe from happening. So that's another priority that we are spending a lot of our money. Definitely, building data relay satellite around March is a priority, and we'll fund it in due time. And optical communications, we are evolving it such that it can provide the operational capability by a certain time frame. But now we are still working the basic technology.
But you made a mention of the streaming video has to be on the spacecraft.
Yeah.
Right. It's not just.
Yeah, to get that streaming video, you have to invest in the mission side as well. They have to be able to have
Yeah, but
ability to
without the capacity to support streaming video, they can put all kind of things, gets nowhere. So we are really working it together. We are working the user terminal as well as the terminal for our data relay satellites.
Yeah, do the Australia and Spain sites have the capability to track the same, all of the spacecraft you can communicate with here?
yes, as long as they're in view, as the Earth rotates. Yeah, we try to.
The same equipment is installed at all three sites. So
Right.
again, common. The user should not care which site is tracking and which time. The data gets handled and the interfaces are all the same.
We try to have commonality throughout the network so that we can spare devices easy and replenishment and things like that, so it makes it much more cost effective.
What do the partner countries get out of it? Do we pay rent on the land there, or?
Workforce, we invest money into local companies and when we make upgrades and changes to the systems. Like we're building antennas in Australia right now. The workforce is being supplied by the Australians locally. Companies that provide the cement, the rebar. So they get something out of that. When we invest, for example, in Spain, the Spanish company is actually building the steel structure part of the antenna that's going in Australia. So they're getting income to local companies in Australia, in Spain, to support the antenna in Australia.
There's also a prestige factor too. They like to say that they're involved and to brag about their capabilities.
We own the facilities, right?
The land is owned by the local governments. The facilities are owned by NASA, the buildings and such. And then we pay for utilities. So there's income coming into the countries.
There's also the science component.
Right.
Country-specific get an opportunity, their scientists get an opportunity to do the
Local country radio astronomy.
Lots of papers come out, PhD theses have come out.
Got some questions over here.
Hi. When you're talking about 40% savings and 75% savings, I think that's pretty incredible. What can we do to help you guys get more funding and put more of the focus on research and development through NASA?
Well, maybe I'll let Badri talk to that. I'm a glass is half empty type of person, and we see the money they send us, and we hope that it's going to keep coming.
Again, as a program manager, you really need to create some certainty and predictability about your program. You can control the things that you can do. We went after the 40% because we believed that we could do the job a little bit better. And we had to invest a little bit in technology such that this investment will return dividend in saving us money by relying more on the machine than people and trying to improve the processes that we have to optimize them and to make them less costly. Now, what you can do, definitely the value, not to my program, really. We have a nice leadership that's listening to us, but it's not just my program. NASA as a whole will need definitely the right funding, but we are working it with the administration, educating the public, sensitizing the people, creating the constituency that require that will definitely help. But in terms of lobbying, I cannot ask you to do any of that. We don't do that. We are actually not allowed to do that.
So you guys really seem to have your act together. I'm super, super but kind of a harder question. What keeps you up at night? What do you, besides money, what do you worry about? You know, when you go home at the end of the day, I think about your next day.
Working up at night is my boss calling me at all hours. I
mean, is it a 24/7 operation? What is it?
No, listen, again, there are many people that, you know, they start any challenge by look at all of the things you cannot do, all of the half-empty situation. That's not our policy. We try to maintain a can-do attitude from the beginning. We said, you know, we gave value to that content, and we try to do the most we can get with whatever we have. We did not let the money stop us. We created the condition to find the funds. Definitely working a program that stretches, and you know, from East Coast to West Coast, and having support from different centers. Every center was different culture, different you know, business practices, and trying to harmonize, trying to bring the whole thing as a unified team did keep me awake in the past. But I have a strong team. You know, recently we had a program implementation review, and they evaluated the performance of my team, and they found it superb. They found the management superb. So I sleep comfortably at night. I have people that I can depend on. Nothing keeps me awake except probably snoring that comes every now and then. I don't want to get into that area.
From an operational standpoint, there are basically two things that keep me awake at night. One is the safety of the people in the DSN that are doing the work. You'll see on the 70 meter, it's a large structure. People climb all over that thing. It's a large moving structure. So the safety of the employee really is what keeps me up at night, making sure that's taken care of. And then I worry that some mission is going to get into trouble and we won't be there for them. That there's going to be some fault that keeps us from answering the phone call that allows us to help save that mission. So those are the two things that primarily keep me awake.
Again, when you have a strong team and you have people doing the worrying for you, at my level, I'm sleeping comfortably. Again, we have a great, you know, our team is so dedicated. Our team is a can-do team. You give them the challenge, they go after it. They complain about the money, who doesn't? But even when they don't get it, they still accomplish. You cannot let these challenges be a limiting factor. As a species, as a NASA entity providing the gateway for all of NASA's exploration, whatever, we need to keep on moving forward, and doing our best, even with what we have, to provide new capability and better service to our customer. We are an enabling entity. What keeps us awake probably sometime is, you know, people not seeing the value that we are contributing, that down the road, 10, 15 years down the road, we don't see the young, fresh mind coming out of school to occupy the key positions that we have our leaders occupying now. We are getting old. Much of the discipline that we have, microwave engineering and whatever, is not the kind of things that's being promoted much at school, but it's so inherent to all of our space exploration, even when you get into the sensor design. So we really need to get the new crops of talent, new people going after engineering, physics, and math. It's reaching the critical point. You guys need to help us to get the message out and to sensitize these guys that science is great. You know, exploration is wonderful and it's very rewarding, even financially. As an engineer, we don't worry about our salaries. We are getting a comfortable salary compared with the general population. So there is money to, there is a way to live comfortably while you are contributing not just to yourself and to your community, but to humanity as a whole. So you guys are my best, thing now. With your tweeting, you're getting the messages out. I'm telling you, you guys are worth your weight in gold, and gold is pretty expensive these days.